All right, today in this video we're going to be talking about what is volume, what is the formula for volume, and how to use that formula to find the actual volume of a particular 3D shape. So first, what is volume? It's the amount of space that a figure encloses. It is three-dimensional. It is always answered in cubic units, cubed. So it's the amount of the space that a figure encloses, meaning like if you have a box, how much stuff can you fit inside that box? If you have a water bottle, how much water or liquid can you fill in that bottle? Sometimes when you move, you'll have moving vans, and they will give you the size and volume of how much stuff you can fit in that van. Because if you have a really big house, you need a really big truck to fit everything in it. If you have a smaller house or an apartment, you don't need as big of a van to move everything in. So volume, how much stuff you can fit inside of something. All right, so in this lesson, we are going to be going over what is big B versus little b. All right, big B versus little b. So in elementary school, you talked about the fact that volume, you did rectangular prisms, which is base, capital B times H. You've also done rectangles, where area equals lowercase b times H. So, if you notice, the difference between this volume is a 3D shape. You did lowercase b times h. This was a 2D shape. So the capital B stands for area of the bottom shape. Capital B stands for area of the bottom of the 3D shape. Okay. Lowercase b is usually the bottom line of a 2D shape. Lowercase b is the bottom line of a 2D shape, and it's usually, not usually, I shouldn't say that, is attached to a right angle. Lowercase b is the bottom line of a rectangle, of a triangle, and it is always attached to that right angle. Okay, I'm going to erase this. So, again, big B, area of the bottom shape. So how do we determine what the bottom shape is? So let's look at this rectangular prism. So in elementary school, you wrote down a volume equals capital B times H. Of course, you knew it's a rectangular prism, so the formula you always went to was length times width times height. Length times width times height. All right. So on a rectangular prism, does it matter which rectangle is on the bottom? No, because they're all rectangles, and regardless of whatever rectangle's on the bottom, if I find the volume and multiply three numbers, it doesn't matter what order I multiply the numbers. That's called the commutative property of multiplication. If I put 3, 4, and 5, if I did these in this order, 3 times 4 is 12, 12 times 5 is 60. If I did it in the other order, if I said this was my bottom, 5 times 4 is 20, 20 times 3 is 60 units cubed. It wouldn't matter, again, what order I multiplied them. That's called the commutative property of multiplication. Okay. So again, capital B, area of the bottom shape. On this one, it did not matter what my bottom shape was because they're all rectangles. All right. Erase this. Now, so I actually have the dimensions for a rectangular prism. So we're going to use our formula, volume equals, you always start off with the generic formula, capital B times H. Next, I'm going to write down the specific, sorry, my phone's going off. Now I'm going to write down the specific formula, length times width times height. Every time we have a formula, you plug in what you do know to solve for what you don't know. So I have 7. Now normally I keep my fractions as fractions because fractions are cool. But since we have 1/2 on all of them, I'm going to turn those into 7.5 and 2.5 times 4 times 2.5. And again, in middle school, we don't use x's for multiplication symbols because your x is a common variable, so as to not get them confused, either you use dots, which I don't really prefer because we have so many numbers with decimals, we use parentheses. So length times width times height. Since we're multiplying three numbers, it doesn't really matter what I label as the length, the width, and the height, but I put them as such. Now I'm going to multiply them together. 7.5 times 4 times 2.5, and you get your volume is 75. And again, it's always units cubed. So it'd be 75 cubic inches or 75 inches cubed. So on a rectangular prism, it's really easy. Capital B stands for area of the bottom shape. It doesn't matter what the bottom shape is. We can just say it's this. So we did 7.5 times 4 to find the area of that bottom shape. And then 7.5 times 4 is 30. And then 30 times your height times 2.5, and that will give you 75. And again, it's always in cubic inches, so it's 75 inches cubed. All right, so that's how we do a rectangular prism, which again you were exposed to in 5th grade. All right, so now we have a triangular prism. Let's go ahead and write down the formula. Volume equals base times height. For a prism, it's always the same. Volume equals capital B times H. Capital B stands for area of the bottom shape. So how do I know what the bottom shape is? Well, listen to the name. It's a triangular prism. So what do you think the triangular or the bottom shape is? That's right, a triangle. So this is my generic formula. Now I'm going to write this formula specific to what I'm dealing with at hand. So volume, I'm going to write down the formula for area of a triangle, which is lowercase b times h divided by 2. Now that's a formula for a triangle. And then I also have my h here times h. Okay, and that's a height of the 3D shape. Height of the 3D shape right there. Okay. So there's no units on here, so let's go ahead and make something up. Let's just say this is 4 units across from here to here, and the height of that triangle is 3 from here to here. Okay, and we'll say the height of the prism is 6 units. So this is 6 units high. 6 inches, 6 miles, who cares? So now I have all the information I need. Okay, I have the dimensions of the triangle. My lowercase b was 4. My h for the triangle, the height of the triangle, the 2D shape is 3. The formula is base times height divided by 2. And then I multiply by the height of the prism, which was 6. So I'm going to plug everything in now. So again, I start with the generic, go to the specific formula, and then I plug in what I do know to solve for what I don't know. So it's 4 times 3 divided by 2. And then over here, we'll write 6. I have to follow the order of operations. So 4 times 3 is 12. 12 divided by 2 is 6. And then 6 times 6 is 36. 36 units cubed. Again, start off with the generic formula, capital B, volume equals capital B times H. When I say generic, that means it's a formula that works for any prism. Then I go next, I'm going to do this in blue, the formula for that specific 3D shape I have. On this one, it's a triangular prism, so what's my bottom shape? It's a triangle. Mr. Hewlett, but the rectangle's on the bottom. I'm aware, we can just tilt it over like they did right here, and now the triangle is on the bottom, as you can see in red. Formula for a triangle is lowercase b times h divided by 2, base times height divided by 2. To find the area of the triangle, the bottom shape, and then I multiply it by the height of the prism. Next step is let's do a different color. Let's do green on this one. Then I plug in what I do know to solve for what I don't know. Okay, I know my lowercase b is 4 times 3 divided by 2. And then I multiply by the height of the prism. Follow the order of operations, and if you plug it in the calculator correctly, you will always get the right answer, assuming you plug it in the calculator correctly. 4 times 3 is 12, divided by 2 is 6, and 6 times 6 is 36, and it's always units cubed. All right, that's how we do a triangular prism. Ooh, volume of a cylinder. All right, so volume of a cylinder. Now, what kind of shapes do I have? I have two circles, top and bottom, and then I have a rectangle that you curve around the circles to make a cylinder. So what's my formula? Now, this one's easy. Volume equals capital B times H. Capital B times H. But that capital B stands for the area of the bottom shape. So what's my bottom shape? I have a circle here. What's my formula for area of a circle? Pi r squared, as you can see right here. And then I multiply it by the h, which is the height of the 3D shape. Now on your calculators, whether it's an app on your phone or it's a scientific calculator, you're going to have a pi button. So pi is the relationship between the diameter of a circle and the circumference. Circumference is the perimeter of the circle. We don't call it perimeter because there are no sides, no straight lines. So it's pi. Now r stands for the radius. The radius, now let me erase this. The radius is halfway from the center point to the edge of the circle. This is the radius. Again, it goes from the outside of the circle to the center point. All the way across is the diameter, but halfway across is the radius. Okay? So we're going to do radius squared. And so let's give a dimension for this. Let's say it's 5 inches. Okay? We'll say the height, if that's 5 inches, we'll say the height is 12 inches. Okay, so let's plug in what we know. We know our radius is 5 squared, and we know our height is 12. We must follow the order of operations. Okay, we started off with generic formula. We went to the specific formula, finding that area of the bottom shape, which is pi r squared, because it's a circle, and then multiplied by the height of the cylinder. And then you plug in what you do know to solve for what you don't know. That's a squared. So community property multiplication, we have to do the exponents first. So 5 times 5 is 25. And then after that, it doesn't matter what order we do it. So 25 times pi times 12 gives you approximately, since we're using pi, and pi is an irrational number, and you can't write it in the form of a over b, it's a decimal that goes on forever, infinitely long, with no pattern. Our answer is always going to be approximately, because we're going to have to round, we're doing squiggly lines for approximately, 942.477. So we're going to call it 942.5 inches cubed. Inches cubed, and that is my answer. That is the volume of that cylinder above. Because again, start off with generic. Volume equals capital B times H. That capital B stands for area of the bottom shape. Our bottom shape is a circle, which is pi r squared, times the height of that 3D shape. Plug in what you do know to solve for what you don't know. Volume equals pi times the radius, which is 5 squared, times 12. Plug it in the calculator. You can check it by hand if you want. On the 8th grade STAR test, you do get to use the calculator. Plug it in the calculator, and you get around 942.4777961. So again, on this one, it's just better to round. So approximately 942.5 inches cubed. All right, that's how we find the volume of a cylinder. Next, we're going to go to volume of a cone. Okay. So our volume of cone is 1/3 pi r squared times height. I should have started off with volume equals capital B, 1/3 capital B times height. That is our initial formula. And then we go to this formula. Why? Because our bottom shape, you notice, is a circle. And the formula for area of a circle is pi r squared. Now, you may notice that this formula looks very similar to the formula we just did. The difference is it's a 1/3 in front of the pi r squared times the height. Where did this 1/3 come from? Well, if I had a cylinder with the same dimensions for the circle on the bottom. Okay, just pretend, work with me here. Pretend that's a cylinder, okay? If I had a cylinder that is the same height and had the same area of the circle, the bottom shape, the big B, as a cylinder that was the same height and the same circle on the bottom, it would take 3 of the cones to fill up one cylinder that is the same height. So again, I had a cylinder that's the same height as a cone and the circle was the same on the bottom. It would take 3 cones to fill up one cylinder. That's where the 1/3, because it's 1/3 the size of a cylinder with the same height and the same area of the bottom shape. All right. So now let's look at our formula. Volume equals 1/3 capital B times H. Then I write down the specific formula. Volume equals 1/3. Stays the same. The capital B is pi r squared because our area's bottom is a circle on the bottom, pi r squared, and then times H, the height of the 3D shape. Now if our radius was, we'll say 10 centimeters, and our height was 20 centimeters, what would our volume be? So what we're going to do next is we're going to plug in what we do know to solve for what we don't know. We know 1/3. We know pi is pi. We know our radius is 10 squared, and our height is 20. Oh, ran out of room. That's a 20 right there. So what we're going to do now is plug in what we do know to solve for what we don't know. So we're going to type in the calculator. The way I'm going to type this in is I'm going to do pi times 10 squared times 20. So let's do pi times 10 squared times 20. And that's going to give me 6,283.1857. So we'll just say 0.19. And then I'm going to divide that by 3 because technically it's times 1/3. And those cancel out. So technically when I'm multiplying by 1/3, that's dividing by 3. That gives me a volume of approximately, since there's pi, it's going to be an irrational number, 2,094.395. So we're just going to call that 4 centimeters cubed. Now look at what I did. Start off with volume equals 1/3 capital B times H. Then I write down the specific formula. Volume equals 1/3 pi r squared, area of the circle, times H, the height of the 3D shape. Plug in what you do know to solve for what you don't know. Volume equals 1/3 times pi times 10 squared, because that's my radius. Radius is half the diameter, times 20, which is the height of my 3D shape. Plug in the calculator. Again, I just went ahead and multiplied everything. Pi times 10 squared times 20 gave me about 6,283 and 1900ths. And then multiplied it by 1/3, and multiplying by 1/3 is the same thing as dividing by 3, and the answer was approximately 2,094 and 4/10 centimeters cubed, because again, our answer is always in cubic units. So that is how you find the volume of a cone. All right, do I have anything else? All right, great. Our last thing is the volume of a sphere. Okay, let's start off. Now this has a very specific formula. Volume equals 4/3 pi r cubed. Notice the cylinder and the cone had pi r squared. On this one, we don't have a bottom shape of a circle. This is a sphere, so it's slightly different. But the formula, we don't start off with capital B times H. The formula is 4/3 pi r cubed. So, as you can see in the diagram here, they have the radius right here. And let's say the radius is 6 miles. It's a really big sphere. Okay. So, write down the formula. Then you plug in what you do know to solve for what you don't know. I'm going to start down here so I have plenty of room. 4/3 times pi times the radius, and we said the radius was 6 cubed to the power of 3. Once I get to this point, I'm going to plug it in the calculator. So the way now the calculator usually has a function where you can type in 4/3. You can't convert 4/3 into a decimal because it's a repeating decimal, so you can't ever put enough 3's. So I'm just going to go ahead and do pi times 6 to the power of 3, which is going to give me 678.58. Goes on forever. It's an irrational number, but I'm just going to round right there. Next, I have times 4/3, which is remaining. So this is 678.58. And then what I have left in the equation is times 4/3. So I'm going to multiply that by 4, the 678, and I get 2,714 point around 336. We'll stop there. Now that's multiplying by 4, so that gets you 2714. I'm going to round right there. That takes care of the 4. But then I have to divide by 3. Divide by 3, and that gives me approximately 904.78 and miles cubed. All right, so this one calculator definitely comes in handy. So volume equals 4/3 pi r cubed. Plug in what I do know. 4/3 stays the same. Pi is pi. But my radius was 6. So on the calculator, I did, and it doesn't matter. There's multiple ways. On the calculator, they do have a function where you can type in 4/3. I can enter it all together. But on this, I did pi times 6 cubed, which gave me about 678.58. Then I multiplied it by 4, multiply numerator by numerator, gave me 2,714.336. It was an irrational number, kept going. I divided that number by 3, and then I'm done, and the answer was approximately, again, since you multiply by pi, it's going to be an irrational number, 904.78 miles cubed. All right. So I know this is a long video, but this is how we find volume of different shapes. So again, going back to the very beginning, what is volume? Volume is the amount of space that encloses a figure encloses. Is how much you can fit in something. It's always 3D, and your answer is always going to be in cubic units, cubic centimeters, centimeters cubed, inches cubed, so on and so forth. Big B versus little b. Again, little b, that bottom line of a 2D shape, always attached to the right angle. Capital B is the area of the bottom shape of a 3D shape. This is 3D. This is 2D. Okay? So area of the bottom shape of a 3D shape is capital B. And again, what's the bottom shape? It depends upon the name. It will usually tell you the name. This is a rectangular prism. They're all rectangles, so it didn't matter. So we could just say this is our bottom shape. So for any shape, you identify the 3D shape, what type it is. You write down the formula. Volume equals capital B times H. Write down the specific formula. And on each of these, we plugged in what we did know to solve for what we didn't know. And on all of these, I think, except for the first one, they were rational numbers, so we had to round. And make sure you're always circling your answers so the teacher can quickly find out what the answer is and move on. So I hope this lesson on volume has been helpful. If you have any additional questions or concerns, feel free to email me at jhewlett@leisd.ws. Thanks.